Assalamu alaikum. Welcome to lecture number 20 of Software Requirements Engineering CSE305. I'm Dr. Naveed, and today we are going to discuss specification process. Before we start our today's lecture, let's quickly recap what we did in our previous lecture. In the previous lecture, we concluded our discussion on negotiation process, and that was a topic which we continued from lecture number 18. And when we finalized this negotiation process, we sort of tried to summarize that what are the different activities we conduct within our negotiation process. And out of those activities, we said that we try to rank our requirements, then we try to do risk assessment, then we also try to make a rough guess in terms of how much the development time would it cost to fulfill each requirement. And finally, we start an iterative sub-process, that is the reconciliation process, and that is the main goal of negotiation. All the above activities are done in order to facilitate a negotiator to actually be able to reach a consensus with all the stakeholders. And the main purpose of the negotiation process is that everybody reach a consensus, so that all the stakeholders and so all of them, they are on the same page, the client, the contractor, and everybody, you know, they're happy with the final rank of requirements and with the final set of requirements that you have. Then in our last lecture, we started our next sub-process of the software requirement engineering process, and that is the specification process. It is one of the most important process. If I say it's the most important process because it produces one of the most important document of a software project, and that is software requirement specification document. So one of the main work products of the software requirements engineering process is the software requirement specification document, and in particular, this SRS document, that is a deliverable, or that is a work product of this specification process. So that's why I say that specification is one of the most important process. So so when we started discussing the specification process, we sort of quickly recapped what a requirement is, and we said it is something which describes a feature or attribute or a service of a product or of a system that we are going to develop. It can also be a constraint on the system. It can be a constraint on what sort of development environment to be used, or it can be any other kind of constraint on the product. And then we sort of identified what are the different types of requirements. And when we discussed different types of requirement, we said there are two different types of requirement. One are user requirements, and then we have system requirements. And then we sort of try to differentiate, and that a user requirement is generally more abstract. So that is how a user generally expresses a user story. But when we have to produce this software requirement specification document, we need to go into a lot of detail, and that's why we go through all those processes. We go through analysis, we go through negotiation, and then we come to specification, because we want to generate system requirements from user requirements. And then we sort of identified that who are the different users of this user requirement, and what are the different users of system requirements. And this is something which we emphasized in our earlier lecture as well, that software requirement specification document is written once, but it is used throughout the life cycle of the product. So you will write this SRS document first. That's why writing or specifying requirements in a better fashion is so important, because the person who writes this software requirement specification document, he is not the only user of this document. There are lots of other people who are going to use it throughout the life cycle of the product. All the designers, all the developers, or the engineers, the client, the project managers, all the people who has anything to do with this product, all the stakeholders, they are users of this this particular document. And specifically in terms of software requirement specification document, we say that the system architects and the system designers, system testers, and on the client side we have some client managers who will be there to validate all the requirements. You know, they are the people who are the users of this system requirements or software requirement specification document in particular. Then we discussed, we sort of continued this discussion of user and system requirements, and we looked back at an example of how a use case is actually used to derive requirements. And again, you guys can relate it back to our discussion on scenario-based modeling, where we discussed the example of the ATM machine, and we discussed our use case in particular, that is withdrawing cash from an ATM machine. And we saw that this particular use case or the user requirement initially was written at a very abstract level, that a user withdraws cash from an ATM machine. Now that is a very high level of abstraction, but when we drill down and we sort of try to identify what are the different things that would be that a system would have to do in order to enable an actor, or in order to enable somebody to withdraw cash from the ATM machine. We saw that somebody has to enter and first of all enter the card. Our machine has to actually check whether the card was entered in the correct orientation or not. Then a pop-up would appear. Then there should be a message to the user of the machine that which language you want to select. Then there should be a message, enter your PIN number. Then your machine need to process the PIN number and authenticate it with the banking system, and then display the menu of different transactions to the user, where he would then select withdraw cash, and then basically that our machine would again need to talk to the secondary actor, which was the banking server. And we sort of listed down all these normal flow of events, and we also identified when we make a use case, we not only identify these normal flow of events, we also try to identify what are the exceptions that can occur during this normal flow, and what are the alternative scenarios that can occur. So these use cases, they're very useful, and that is all our discussion in analysis was about, that we have user requirements at a very high level of abstraction, and we want to increase our understanding, and we want to identify system requirements, and that's why we go through all that analysis. Then finally, towards the end of the last lecture, we discussed characteristics of a good SRS. And we have emphasized on this topic earlier as well, and we said that, you know, for example, when we were writing an SRS, we need to use a language which is understandable to all the people, because not everybody is from the same background. But we sort of really listed down all the factors or all the good characteristics of an SRS. For example, we said that all the requirements written in an SRS, they should be correct. One thing that we discussed with correctness, that it is very difficult to gauge correctness. So it is done only through personal judgment and through experience that we identify whether this particular requirement is correct or not. So we want to identify all the ambiguous requirements, because one of the good characteristics of the SRS that it should not have any ambiguity or any ambiguous requirements. So we want our requirements to be unambiguous. So, and another thing that we discussed, that there shouldn't be any conflicting requirements. So we have done negotiation, so our understanding should be that, you know, these things are resolved, but when we are specifying, we might identify these things again. So that's why we always say that, you know, it's an iterative process as a whole, this requirement engineering process. So we can go back and forth between these different sub-processes of a software requirement engineering process. So what does a conflict mean? We discussed that there can be multiple kind of conflicts. There can be logical conflicts. There can be conflicts in the use of a particular terminology, or there can be conflicts in terms of a functionality of a particular feature or of a particular process. So another thing we discussed, that the requirements that we write, they should be testable or verifiable. This is very important. Why this is important? Because, and that's why we keep on emphasizing that even the non-functional requirements, when we are expressing non-functional requirement, we discussed this in terms of the functional requirements, but even when we are discussing non-functional requirement, it is really important to quantify those qualitative statements. For example, good or well, you know, these statements, they are not testable. So because goodness means different to different people. For example, I might have a different definition of good, whereas you have a different definition of good. For example, for me, goodness may be 90%, and for you, it might be 70%. So it's for example, so everybody has different scenarios, and everybody has, so that's why we try to get rid of all these subjective terms, and we want all the requirements to be testable, because when we do these things, then we resolve ambiguities, we resolve all these problems with the requirements. So we want our requirements to be testable, so that we can actually verify them at the end when we are delivering product to our client. So that is what we discussed in our last lecture, and so let's quickly look at what we are going to do in our lecture today. So we will continue our discussion on the specification process. We started looking at specifying functional requirements in our last lecture. So what we are going to do today is we are trying to establish what are good and bad requirements. We are going to look at few examples, and we will sort of try to educate ourselves that, you know, how to express functional requirements in a better manner. And then we'll move towards specifying non-functional requirements. And as I said it in our initial lectures on software requirements engineering, that usually it's simpler to specify functional requirements, but non-functional requirements, they are tricky, and people find it really difficult to specify non-functional requirements. So we are going to discuss how we can specify, or how we can write these non-functional requirements, and what are different categories of these non-functional requirements. But before we get to it, let's look at some examples and try to identify that what are good and what are badly written functional requirements. So for example, you know, we have this requirement 1 which says only authorized persons are allowed to enter the building. Okay, and the requirement 2 is says the doorbell button should be blue, round, and with a diameter of 20 mm. Now requirement number 1 is a goal, requirement number 2 is a detailed specification. In fact, requirement number 2 is in fact 3 different requirements. So when we specify, for example, this requirement number 1, that is at a very high level of abstraction, because this can be something that a user expresses, that the people who are entering the building, they should be authorized. Whereas when we are saying requirement number 2, that is a detailed specification. We are actually mentioning the small teeny details of the product as well. We are saying the doorbell should be this, it should be of this color, the size of the, so there are actually multiple requirements in that particular requirement. Similarly, let's look at this example number 2, requirement number 4. The system shall play the sound alarm when the door is opened. The system shall play the sound, and we are actually telling that which alarm to actually play once, at the highest volume setting in the main speaker for the building when the door opens. So we are actually, you can actually see the difference between these two requirements. So one is just saying that the system should sound the alarm, and there are lots of ambiguities in it, that which sound to actually play as an alarm, and similarly in which speaker it should play, and what should be the volume of that particular. So we are actually putting in more detail about a particular requirement. And let's look at another example. The system shall respond quickly to user interaction. Now again, as I said, just like a statement good, which is a very subjective statement, so we are saying the system shall respond quickly. Now quickly might mean different things, and for example, when we take it, we write this particular requirement and we take it to our client and say, okay, the system this is your product, and he is actually sitting down and testing it, and he says, okay, so this was the requirement that the system should respond quickly, and but it is not quick. So the client can easily say that because we did not actually mention what does quick mean. Okay, so what we can do here, we can specify this requirement in a quantitative fashion, and what we can write is the system shall respond to user interaction within maximum 2 seconds. So we are now it is testable, because before actually going to the client, we will ensure that it responds to all the user interaction within 2 seconds. If it does not, then it does not satisfy this particular requirement, and if it does, then your client cannot actually say you that this is not quick interaction. Minimum 0.2 seconds, average 1 second, with a CPU load of 0. So I mean, we are putting a lot of detail here, and the purpose here is that we are trying to remove all the ambiguities from this requirement. We want our requirement to be testable, we want it to be verifiable as well. So that is the difference, again, another difference between a good and a bad, between a bad and a good requirement. And let's see a few of the more examples. There are 4 classes of users in the system: maintainer, administrator, normal user, and guest. A guest user is able to enter areas X1, X2, and X3. A normal user is able to enter all the areas in the building. An administrator is a normal user who also have the right to add, modify, and delete users in the system. A maintainer is a guest who is able to enter area X99 and perform backups, view system logs, and add, modify / delete users. Now, if you look at all these requirements, and they are sort of they are written at the right level of detail, because we are mentioning that what kind of users are going to use this system. So we are actually mentioning what are the different levels of the users, and then again we are saying that again. Remember this initial requirement number 1, which said that only authorized users should be allowed to enter the building. Now this is actually, we are writing detailed specification for that particular requirement. We are saying that there are 4 classes of users. So we have maintainers, we have administrators, we have normal users, and then we have guests. So we are saying that a guest user can only enter in these following areas. So he would only have access to certain portions of the building. But then we are saying that as a normal user, they can go anywhere in the building. Then we are talking about administrator, that they are also normal users. So it means that they can go anywhere in the building. But they also have additional rights where they can add, they can modify, and they can delete existing users. And then we're talking about maintainer, that a maintainer is a guest who is able to enter area X99. So a maintainer is a special kind of a guest. So it cannot enter those 3 areas where a guest can enter, but he can enter a specific area because their purpose is to take backups, their purpose is to view system logs, and add, modify, and delete users. So this again, you can relate it back to that level, that where we say that the user requirement, they are generally abstract, whereas when we are going to specify these requirements, we have to put in detail in them. Okay, and then we have this requirement number 6, which says users and their access rights are listed in table 1. So we are saying we have these user classes, And so this is how we specify requirements which removes all the ambiguities. We are saying that these are the 4 user classes. We have guests, we have normal user, administrator, and maintainers. Areas where they can enter. So for example, we have these 99 areas from 1 to 99, and we are specifying very in a very true Boolean fashion. We are saying yes or no, that either somebody has an access to this part of the building or not. So as we know that the normal user, they would have access to all parts of the building, and administrator, they also have access to all parts of the building. But the guests, they can only enter in certain areas, which we mentioned in our last slide as well, x1, x2, and x3, and they cannot enter the maintenance area, whereas the maintainer are saying that they are special kind of guests. They cannot enter in x1, x2, and x3 area, but they can go into this special area where they can take backups and they can view logs. And then we have another field where we are saying that which of these users has the rights to add, modify, and delete users. So as we discussed in our last slide as well, that the guests and the normal users, they do not have rights to add and modify users, whereas administrators and maintainers, they have these rights. Then another role which is assigned to one of these users is backups. So we are saying that who of these different classes of users can take backups. So we are saying that the guest, normal users, and administrator, they cannot take backups. So we specifically write under this particular functionality of backup that these 3 users, they cannot take backups, whereas the maintainer, whose role is to take backup of the system, he is only allowed to do that. So we are specifically mentioning the authorization of different kind of users to this particular system. And then another functionality which we want to give these users is view logs. And out of all these users, we have only 2 people or 2 classes of users who can actually view logs, and those are administrators and maintainers. So again, we are specifically saying that the normal users and the guest, they cannot view the logs, whereas the administrator and the maintainer, they can view logs. So this is how we can actually get rid of all the ambiguities. And you said this fashion, if we write this particular requirement, so this is the same thing that we expressed here, but it can be expressed in this particular fashion, and it would be very clear and very easy to interpret for everybody or every user of this document, because they can actually see and say, okay, so all the yeses means that we have to give access to this kind of a user to this particular area of the building, whereas all the no's mean that this user is not allowed in a certain portion of the building. So this is how we can specify, we can remove all the ambiguities from the requirement that we specify. Then another example is that when a user enters a correct code, the door shall open. So again, we have just mentioned that a user enters a correct code and the door shall open, whereas we said that there should be actually more detail in it, because let's say a user enters the correct code and the door opens. So how long should the door should the door remain open? Should it be closed as soon as the user enters the building, or should it be unlocked for a certain portion of time? Because we do not want any unauthorized person who is following this particular guide to enter the building. So we need to enter more detail into this particular requirement. So how we can write this requirement which is more clearer and which is more detailed? So we can say that when a user enters the code associated with him or her on the keypad K2, so we are actually specifying what is the keypad, and the door D2 shall unlock and remain unlocked for 30 seconds. So we are actually specifying the duration for which the door should be unlocked. And it is not so one ambiguity that might have been there, that how long should the door be unlocked. So we are actually getting rid of that. We are saying that it should be only for 30 seconds. So few more examples. So we are saying that when a user has entered the building, this shall be registered in the entry log and the user's computer shall be booted. Okay. Whereas another way of expressing that is when a user has entered the building, this shall be registered in the entry log. When a user has entered the building, the user's computer shall be booted. So first of all, when we are writing this requirement, we should try to identify that whether we are actually mentioning multiple things in one statement, or we are trying to write multiple functional requirements as one requirement. So we should never do that. We should always try to distinguish if there are multiple things happening in one requirement, we should split them. So as this particular example suggested, that because there were 2 things which were happening in this particular requirement. So as I was saying that there are multiple things happening in this particular requirement, you can see that here that there are 2 things happening. So one is that when a user has entered the building, this shall be registered in the in the entry log. So one requirement should be ending here, and this is the other requirement, that the user computer shall be booted. So we should always try to identify that if there are multiple requirements written together, we need to spread them up. Another example is that NAE events shall yield a BOTL to the CIC. Now what does that mean? These kind of statements, we need to actually clarify them, that what is meant by BOTL, what is meant by CIC, and what is NAE. So we cannot specify requirements in this fashion. Okay? If we are going to use certain acronyms, we have to give definitions of these acronyms in the start of our document. So we need to have a data dictionary where all these jargons or all these acronyms, we need to define them. So for example, what is meant by NAE? So NAE means non-authorized entry. So we are saying that non-authorized events shall yield a BOTL. So what is BOTL? Bandit on the loose. So it's kind of an alert or a message that you have within your system. Everybody is familiar with this particular term. You're saying that there's a bandit on the loose, BOTL, to the CIC. Who is CIC? It is the commander-in-chief. So you want a certain event to be generated, that there is a bandit on the loose whenever somebody unauthorized enters the building, and you want a particular user to be informed about it, who is the commander-in-chief. So there are three terms here, and if there are no entries of these three terms in your data dictionary or in your list of acronyms, then nobody apart from you who maybe got to know about these words when you elicited requirements from the user as a requirement analyst, no one else in your team would be able to identify these three words. So it is very important that you maintain a data dictionary, or you maintain a list of acronyms which you keep on updating if you are going to use these kind of terms or these kind of words in your when you're specifying these functional requirements or in your SRS document. So finally, what kind of language? Let's look at some of the language guidelines. We talked about them in our earlier lectures as well. But we should use complete sentences. This is very important. We should not leave anything which is not completely written, or it should not give that, okay, this message is not actually complete, because then it would mean that we are leaving ambiguities in our requirements. We should be using correct language. So use of language is very important, and we talked about it. We should not be using too many technical or application domain specific words, because what that would mean that as an analyst, you would be familiar with these words, but your designers or your developers who actually did not go and actually see or actually elicit the requirements at the client's end, they will be unfamiliar with those words. So you should be careful when you are mentioning or use with your use of language. And so these kind of words should be avoided. For example, must, required, and shall should not be used, whereas should cannot be used, and may or optional, these kind of words should not be used. And another thing which is a general rule with writing, that you should keep your sentences short. People generally have a habit of writing long sentences, and this was the case with me as well. When I started off, I used to write very long sentences, and I always thought that I found it easy because when you're writing, you don't actually realize that you have written a very long sentence. So, but when you're specifying requirements, or even in journal, adapt this habit that you need to write sentences very short, because if it's short, it is understandable by everybody, not just by you. We should use active voice rather than passive voice. This is very important, and use terms consistently, because we said that one kind of conflict that is resulted from written requirements is because of you're using multiple terms for the same kind of functionality. For example, as we discussed in our last lecture, that for a user input we can use multiple words. For example, we can use prompt, we can use queue. So these two words, we are using different terms for the same functionality, which can mean that we are leaving conflicts, or we are leaving ambiguity in our requirements. So we need to be consistent with the terminology that is used. We need to state all the requirements in a consistent fashion. So the actor, shall, action verb, and observable result. So kind of we should always use the same kind of, or we should always have very consistent way of writing the requirements. For example, this can be one format that we mentioned. For example, if you are mentioning the interactions of the user with the system, we can follow this particular format. We can say the actor, so the particular type of the user shall do what with the system, so we can put an action word here, and we can also say, okay, what our system is going to do, and what would be the result. And again, you need to avoid all the vague terms. We need to avoid comparative words. So we need to quantify. So all the comparison words, for example, better, well, or good, we need to avoid all these words, because as I've been discussing, that they produce ambiguities in your document. So again, so that is our discussion about the functional requirements, and we have seen some examples of functional requirements, and we saw that what are good requirements and what are badly written functional requirements. Just keep this thing in mind, that we need to be very careful when we are specifying requirements. And always remember that you can understand, if you have understood the system properly as an analyst, you would be able to understand the SRS document. It doesn't matter if you don't care about few of these things, but remember that you're writing this document not for you, but you're writing this document for the client, and you're writing this document for your other teammates who has to actually design and develop and test the product. So it is very important that you think of all the users who are going to read it, and then start and then write this particular document, because then this would mean that it is more usable, and if people are going to use it, only then the product is going to be successful, or your project is going to be successful. So next up we have is non-functional requirements, and so we are going to see what are non-functional requirements, and then we are going to say how we specify these non-functional requirements. So non-functional requirements, they define the overall qualities or attributes of the resulting system. So at times a general statement that is used for non-functional requirements, that all the qualitative requirements go in there as well. So we say that all the qualities or attributes of the system, they are expressed as non-functional requirements. So what do these non-functional requirements do? They actually kind of put restrictions on the system. So they kind of put restrictions on the functionalities of the product. So non-functional requirements, what they do is they place restrictions on the product being developed, the development process, and specify external constraints that the product must meet. Examples of NFR include safety, security, usability, reliability, and performance requirement. So if you have a look at all these non-functional requirements, then they are sort of the constraints that they are putting on the product. They are actually putting constraints on the functionality of the product. So for example, we have certain performance requirement, and a certain feature of the product is that how quick should be the response time to the user, and we specify that the performance of that particular this particular feature should be we quantify it. We say, okay, the system should respond to this particular user interaction or user in 2 seconds or 3 seconds or 4 seconds. So this is kind of a performance requirement. We are putting a constraint on the system, and so we are putting a constraint on the functionality of the product, but this is sort of a performance requirement, because we are expecting our system to be that good. So all these are examples of the non-functional requirements: safety, security, usability, reliability, and the performance requirements. So it's important to actually try to distinguish, as I just said, that when we specify some of these non-functional requirements, they seem very close to the functional requirements. So what is the difference between the functional and non-functional requirements? So there is no clear distinction between functional and non-functional requirements. Whether or not a requirement is expressed as a functional or non-functional requirement may depend on the level of detail to be included in the requirement document, the degree of trust which exists between a system customer and a system developer. So let's look at some of the examples and try to actually identify these differences. So let's say the system shall ensure that the data is protected from unauthorized access. So conventionally, this would be considered as a non-functional requirement, because it does not specify system functionality, because somebody is actually putting a constraint on the system. Now it is saying that unauthorized users, or all the data should be protected from all the unauthorized access. So, but we can specify this in a different fashion, which might make it look like a functional requirement. For example, we can say the system shall include a user authentication procedure where users must identify themselves using a login name and password. Only users who are authorized in this way may access the system data. Now in this particular form, this requirement, it looks like a functional requirement. Why? Because it specifies a functionality, which is this authentication procedure. So we are saying user login. So the non-functional requirements, they can be defined as restrictions or constraints placed on the system service. So specifically, this is from the Somerville book, which says that they are restrictions on the system services. Okay. Now let's go back to our previous slide and try to make some sense of what was written here and what we tried to actually mention here. So we said that whether or not a requirement is expressed as a functional or a non-functional requirement may depend on the level of detail to be included in a requirement document, the degree of trust which exists between a system customer and a system developer. So this is very important, because if this requirement is written in this fashion, so if the requirement is written in this fashion, then the level of detail is actually different than this particular case. So whereas this sounds like a non-functional requirement, because maybe the client and the system developer, they have a very good understanding, and the client knows that when I tell my contractor this particular give him this particular user requirement, he would actually mean that I want this authentication procedure, but when we look at this looks like a non-functional requirement. Whereas if we specify this particular requirement in a different fashion, it becomes a functional requirement, because what we said that we have changed this non-functional requirement, which was a safety constraint. We have changed it to a functional requirement by saying that our system would have a procedure in place which would make it happen. So for example, we are saying that system shall include a user authorization process, which users must identify themselves using a login name and a password. So again, so that is what we meant, that it depends on the level of detail with which this requirement document is written, that then you can differentiate that this is a functional and this is a non-functional requirement. So what are the different types of non-functional requirements? And this is taken from IEEE standard. It lists 13 non-functional requirements to be included in a system requirements document. And so what are these different kind of non-functional requirements? So we have these performance requirements. And we have seen some examples of these performance requirements. If you remember that ATM machine example, and we said that when a user enters the ATM card, then the machine should be able to give response to the user in a certain amount of time. And if there is no response from the banking server, it was a secondary actor, then the machine should say, okay, the transaction has timed out, and here is your card back. So so that was the example of the performance requirement. Similarly, we can put some constraints on the interface of the system that is being developed, how easy or what kind of graphical user interface should the system possess so that it is more usable for the users. Similarly, we can have some operational requirements. We can have some resource requirements that the system should be able to run on this kind of hardware, this kind of a processor speed, and this much RAM should be required for the system. Similarly, we can have some verification requirements. We can also have some acceptance requirements which we can put on our system. Few other types of the non-functional requirements include documentation requirements. For example, that is totally not part of developing some functionality or giving something to your client, but you can have some documentation requirements, because your client might want a detailed documentation of different technologies or different kind of tools that you have used in order to build that particular product. Similarly, security requirements, that is another type of the non-functional requirements. You can have portability requirements. For example, whether the system that you're developing is portable between different platforms or not. You can also have some quality requirements. You can have reliability requirements, that whether the system, how long the system would be functional. Should it be functional 24/7 or should it be functional 8 hours of the day? So these are sort of reliability requirements of the product. Similarly, you can also include the maintainability requirements. So maintainability is another type of non-functional requirements. You can also have safety requirements. We saw one of the example of safety requirements earlier as well. So these are the different types of non-functional requirements. But what we should actually try to figure out that what is the classification of these different types of non-functional requirements. And according to Boehm, the non-functional requirements, they can be classified in terms of qualities that a system must exhibit. So we can classify different sorts of non-functional requirements. For example, there would be some non-functional requirements which would go under reliability, safety, security. So either we can do that, or there is a more general specification which distinguishes between product, non-functional requirements, process non-functional requirements, and external requirements. So all the constraints that we are putting on the product, on a system or a software as a product, then all these would be expressed under this particular category of product or this particular class of product non-functional requirements. Then we have some constraints on the process that is being used to develop that particular product. These would be the process non-functional requirements, and then we are putting some constraints on our system with how it is going to interact with the external entities, so that are external class of non-functional requirements. So let's have a look at how do we classify different kind of requirements, non-functional requirements. So in terms of product non-functional requirements, so we can say that if you see this particular hierarchical graph, you can see in this hierarchy that we are saying that non-functional requirements can be classified into these three classes. We have process requirements, we have product requirements, and then we have some external requirements. So in terms of the process requirements, we are saying that you might want to put some constraints on your process in terms of delivery, how you are going to deliver this product to the client. Similarly, you can put some constraints on the implementation of the product. So you are saying, or the way the product is going to be implemented. So that is a constraint on the process. So we are saying there might be some implementation requirements, and we are going to classify them as process non-functional requirements, and there can be some standard requirements. If you look at all these three requirements, then they are three different. Then they are actually constraints on the process that is being used to develop and deliver the product. So we are saying either the way we are going to deliver the product, we are putting some constraints on it. So let's write some requirements about them, and these will be non-functional requirements, which would be some constraints on the process. Similarly, we are saying that if there are any specific implementation constraints that the client wants, we need to specify them. So these would be again process non-functional requirements, and then client might have certain standards, and if these are those requirements, or we might need to, or as an organization we might have some standards on the process of developing a particular product, then those would be specified under standard requirements, and they will be classified as a process non-functional requirement. And when we talk about product, within the product we have all these requirements, for example the usability, reliability, safety, efficiency, performance, and capacity requirements. And then the third class of these non-functional requirements are external requirements. So we can actually see that the class of the product requirements, it kind of puts constraints on the product. So usability constraints, for example the user interface requirement, they would go under this. Reliability, performance, how long the system should be able to be active without failing, that are reliability constraints, and they're again on the product. Then the safety constraint, they're again on the product. Efficiency, performance, all these constraints are on the product. Whereas the third class is the external requirements, and there might be some external legislation which actually limits your product in certain fashion, or which actually limits the way in the product is to be developed. So there can be some legal constraints which can be put on the product. There can be some economic constraints, or there can be some interoperability constraints. For example, you're building the system, but the user says, okay, we do have a legacy system, and we want the new system to be able to interact with this legacy system. So that is an external constraint. So it would be classified as an external non-functional requirement of the product. So what are these product requirements? They specify the desired characteristics that a system or subsystem must possess. Most non-functional requirements are concerned with specifying constraints on the behavior of the executing system. So again, if you remember these words, then I don't want you to get confused, but try to relate all these things that we have been discussing. If you remember that when we were in the analysis phase, we said that there are three things which we are interested in. We are interested in identifying the information domain, we are interested in understanding the behavior and functionality of the product. And we said that when we do that, we identify the functional requirements, but we also sort of identify with the system behavior, we identify that what are the limits on the behavior of this particular system. And if you remember that particular ATM example, I keep on going back to that example because it is very easy to explain for me. So now we keep on going back to that particular example, and if you guys remember, we said about that particular performance constraint, we said that okay, the system should respond to a query, to a cash withdrawal query in a certain amount of time, and we put a limit there. And the reason for a limit there was that, you know, you cannot keep just standing there and waiting for your ATM card forever. If the banking service is not responding, then you need to tell the user that there is no response from your bank, and the system is not able to process your request at this moment. So that is a constraint on the behavior of the executing system. So product requirements are generally, you know, we know the behavior of the system through the functional requirements, but now we are putting constraints on the behavior of our system. So how do we specify these product requirements? So some product requirements, they can be formulated precisely and thus easily quantified. For example, performance is something which we can easily quantify. Capacity is something which we can easily quantify. For example, the number of users who can actively use my system at one time, I can define this as capacity. Similarly, performance in terms of response to user interaction or response to all the different user requests, they can be very easily specified. Whereas others, they are not that easy. For example, usability requirements, you know, they are normally not that easy to quantify. So they are normally set, you know, informally. Generally, you know, when you say that usability, what do we mean by usability? That how easy my system should be to use. You know, that is just usability. That I want to make a system which is usable by all the end users of this particular product. So again, this is something that you as a requirement analyst, when you go and talk to different end users, when you're gathering requirements at the elicitation stage, you try to identify, okay, what is the skill set of the different users, and depending on their skill set, you sort of try to build your system, or you give your interface requirements, or you give your usability requirements, keeping the users in the mind that I want to make a system which is very easy to use, so I want to give an interface which people can actually relate with. For example, you know, you can give if it's a paper-based system where people were working, you can actually take those particular forms that people have, and you can build an interface which actually looks very familiar to that, which is very similar to that, so that people can, when look it up on their machines, they can easily identify, okay, this is what I used to do here, I just need to type it here rather than writing it here. So it's important that it is not very easy to express these usability requirements, and that's why they are expressed sort of informally. So let's look at some of the examples of these product requirements. So the first one is the system service X shall have an availability of 999/1000 or 99%. So this is a reliability requirement, that I'm saying that if somebody tries to use a particular service, then it should work 999 out of 1000 times. So if there are 1000 tries of a particular service, it should work on 999 times. So 99% of the time my system should be reliable. Then system Y shall process a minimum of 8 transactions per second. So again, this is a performance requirement. So I'm saying that how quick my system should be. Then the executable code of system Z shall be limited to 512 kilobytes. This is a space requirement which specifies the maximum memory size of the system. So again, another constraint on the system. The request for the user's PIN shall be issued within 5 seconds of the card being entered in the card reader. So again, this is a performance requirement. So we are saying that, you know, when somebody enters a card in the ATM machine, now let's just imagine that machine just waits for, you know, 5 minutes, and you're just standing there and waiting for machine to say something. Now that would be very unacceptable. For example, if I know that I have 5 ATM machines near my home, and I know one of them actually does that, and one of them, it takes 5 minutes, and I just have to wait there, and you know, I would never go to that particular ATM machine. So that's why these performance constraints are put on the system. So this is a constraint on the behavior. So all of them, you can actually see that these are constraints on the behavior of the system. So what we can do about them, we can do some brainstorming when specifying the section of these special requirements in use case development. So again, remember our analysis when we discussed specifically those scenario-based modeling, and we were discussing this particular cash withdrawal transaction of the ATM machine, and we have a section on special requirements. So what we do is that also all the product requirements which are constraints on the behavior of the system, we can identify them if we discuss and if we think more about them. So because we have a special section in our use case which says special requirements. So, and those special requirements are actually constraints on how the system is going to respond to user queries, or how the system is, or on the functionality. So it is important, and we can actually identify them if we actually think through these problems more carefully when we are at the analysis stage. So then let's look at some of the source code requirements. So these are also product requirements which relate to the source code of the system. What are the examples? The system should be developed for PC and Macintosh platforms. This is the portability requirements, which affects the way in which the system must be designed. So I want, so for example, if I want my system to be functional on different platforms, then I need to use a language which actually allows that. So the system must encrypt all the external communication using the RSA algorithm. This is a security requirement which specifies that a specific algorithm must be used in the product. Now, if I am making a system where I need to communicate with the external users or some external systems, then that communication should be encrypted. Now, that is sort of a security requirement, which is again a product requirement that I am putting on my system. So there can also be conflicts in the product requirements. So we are not just saying that there would be conflicts on when we are writing functional requirement, but non-functional requirement, they can also be conflicting. So what are the examples of that? For example, a requirement for a certain level of performance may be contradicted by reliability and security requirements which use processor capacity to carry out dynamic system checking. So so this can happen that we are trying to achieve something. For example, we are trying to achieve performance, but then we have another constraint, which is reliability or safety or security, which is actually limiting the system performance in some fashion. So there can be these things. So we have to strike a balance between all these things. We have to come up with something which is acceptable to the client and which is doable as well. So another example is a requirement on the space utilization of the system may be contradicted by another requirement which specifies that a standard compiler which does not generate compact code must be used. So for example, you've put a constraint on the product that you need to develop the system by using certain kind of a language or certain kind of for certain kind of platform, and you have limited that the development should be done using a certain kind of a compiler which does not allow to generate that compact code. Now, and you have another requirement which is of space utilization, so they are contradictory, because on the one hand you are specifying you are trying to limit the development of the product by saying, okay, no, only do that in this particular environment, whereas on the other hand you're saying no, the system should use less space. So you cannot actually do the both. So so the process of arriving at a trade-off in these conflict depends on the level of importance attached to the requirement, the consequences of change on the other requirements, and the wider business goals. So again, remember our negotiation process. So as we used to resolve conflicts there, we are going to use a similar process. We are saying that if there is a performance requirement and there is a security requirement and they are contradicting with each other, we are going to rank them and we're going to say, okay, which one is more important to the user, which one we think as domain expert is more important. And by going through this process, we are saying, okay, so we identify the important one, we say, okay, let's change it. But when we are going to change it, we also need to understand what would be the impact of that change on the rest of the system. So and more importantly, as we need to identify that, for example, so what are the wider business goals? So we need to identify which one of these requirements is more important to the business goal of the client. So these are the things that we need to keep in our mind when we are resolving the conflicts in the product requirements. So what are the process requirements? So the process, as we discussed, that these are constraints that we place upon the development process of the system. So they include a requirement on the development standards and the methods which must be followed. If you are using any computer-aided software engineering tools, we can also sort of put some constraints on it that this kind of tool should be used. And the management reports which must be provided. So any documentation that we have to do along the way, these are all process requirements. So as we said, any standards, any documentation required, or any limitation on how things should be done for this whole product development or for this whole system, anything that is related to the process of doing something, they are process non-functional requirements. So let's look at some of the examples. So a very simple example can be the development process to be used must be explicitly defined and must be conformant with ISO 9000 standards. So we are saying, okay, this is a standard, you should just follow that. The system must be developed using the XYZ suite of case tools. So it's again limiting the tool that we want in which we want our system to be developed. Then management reports setting out the effort expended on each identified system component must be produced every 2 weeks. So we are again putting on constraints. It is very applicable to our local software industry, because what we do is that we lots of outsourcing being done here in Pakistan, and we do lots of these smaller projects, and the billing is done on monthly or basis, and so we need to tell the client, okay, we have expended this much time on your project. So maybe that's a process requirement that now these companies have on different systems that they're producing, that they need to record all these things, that how much time is spent on a particular project. Similarly, another requirement can be a disaster recovery plan for the system development must be specified. So that is another example of a process requirement. Then the third class of non-functional requirements was that external requirements. So, so what are these external requirements? They may be placed both on the product and the process. So we can have, we remember there were three different kind of external requirements. There can be legislative requirements, and there can be some requirements with the external interfaces. So if there are any legislation, it can be on the process or it can be on the product. So they are derived from the environment in which the system is developed. Right? So external requirements are based on the following things: application domain information, organizational considerations, the need for system to work with other systems, as I gave the example of legacy systems, health and safety, or data protection regulations. For example, if you're building an application for e-health, normally you would have to, there would be some general standards of securing the electronic medical records of different patients. So if there are certain standards, then your system should actually follow them, or even basic natural laws such as laws of physics. So generally, when we try to figure out, okay, what are the external requirements or what are the external constraints on my system, first thing that we do is we try to identify, okay, this is the domain in which this application is going to be used. So we understand that and we identify those external requirements. Similarly, we also try to relate, okay, this is the environment in which my system is going to be used. Now, what are the other system with which this system is going to communicate? So there might be some external requirements which come from there. There can be some health and safety requirements. So all these things, especially when you look at the environment in which the product is going to work or the product is going to be developed, then you identify these, and it helps you identifying these external requirements. So examples of some of these external requirements, they include, for example, as I gave you the example of the medical data system, the organization's data protection officer must certify that all the data is maintained according to a data protection legislation before the system is put into operation. Now, this is something really important, and which lots of people who are working on e-health areas, they are concerned with securing of the electronic records of all the patients. So similarly, that is an example of an external requirement. Similarly, an example from the application domain is the train protection system. The time required to bring the train to a complete halt is computed using the following function. Now, that knowledge only comes from the application domain information. So we are saying that the deceleration of the train shall be taken as this particular function, which actually specifies that about all these things, where we say is that what are the different values of different terms which are used in this particular formula, and so the deceleration of the train shall be taken as that. So we have two constraints. So one is the control and the gradient. So, but this information, it only comes from understanding of the application domain. So we also need to specify that what do we mean by these different terms. So we are saying that the gradient is calculated as so we have expressed a formula for calculating the gradient. So we are saying that we are going to calculate gradient by multiplying this 9.81 multiply by compensated gradient and divided by alpha, and where the values of this and alpha are known for the different types of trains. So we know that if we are going to deploy our system on the trains, we would have to know that for certain kind of a company, we know that which kind of trains do they have, and for different kind of trains these values would change. So we have expressed this particular formula for deceleration but we have use some different terminologies which can be actually taken from the client as well. Similarly, we are also saying that how we express the control. So we are saying that the control is initialized at 0.8, and this value being parameterized in order to remain adjustable. So we are again saying that we have parameterized this value because we will see that how it actually works when we put it into practice, and we can adjust this parameter to gain more control maybe. So again, we can also attach some graphs or some figures to actually help the designers and developers understand this particular requirement. So we can actually see this particular graph, which actually says that which actually shows that this is the train, and this particular graph, it actually shows the speed of the train so there is a small mistake here. We are saying that speed of the train at the change of the gradient, and this is the speed of the train on application of brakes. So there are different gradients for when we apply brakes, then the gradient is different, and so this is important. So what we are saying that this information is particular to the application domain, right? So I mean, it is not important that you understand the physics and all these things in this particular formula, but what is important to take from this particular slide is that, as we said, that the external requirements, they come from understanding of the environment in which the product is developed, and that understanding can be from we can get this understanding by application domain information, we can get this understanding by any health and safety regulations that we have, and similarly we can have know what are the organization considerations. So it is important to understand that if you are making a system which has some particular constraints, and that can only be understood by getting to know the application domain, you need to actually specify them, and not only specify them, because as a developer, a guy who actually writes code, he may not be familiar with what values to be used here for control and gradient, and how to calculate this for a particular train. So we are actually specifying the formulas so that people don't actually play with these things and use the exact formulas which is required by that particular application domain. And we are saying that we are keeping it flexible as well. And why we are keeping it flexible? Because if we can actually change it as well later on if we are not able to achieve certain amount of control. And we have attached this particular graph as well, which actually expresses the same thing. So for example, if we identify any kind of these external requirements, then we need to ask for more from the domain experts, or we need to ask for more from the experienced users at the client side. We need to actually get more information about it, so we can actually be very clear on these kind of very important external requirements. So as I said, the first of the example, so we saw two particular examples of external requirements. So the first of the requirements, it described the conformance to the data protection legislation. The second comes from the application domain and is a specification of physical braking characteristics of a train, as we mentioned earlier as well. So the external requirements rarely have the form the system shall or the system shall not. Rather, they are descriptions of the system's environment which must be taken into account. So this is really important for us to actually understand and keep in our mind, that when we are expressing these external requirements, then they are really hard constraints, and system would not be acceptable if the system if the system does not comply with them. Very simple as that. So they can never be in the form of shall or shall not. The system should have those things, because the client has mentioned, or the system or the application domain actually requires that it should have this. The system should conform to these particular standards or these particular requirements. So that is it from today's lecture. So let's quickly summarize what we have talked about in today's lecture. So in today's lecture, we started with discussing functional requirements, and we sort of tried to figure out that what is a good functional requirement and what is a bad functional requirement. And we looked at different examples that when we are writing or when we are specifying requirement, when we are producing the software requirement specification document, we need to ensure that we put a right amount of detail in the requirements. So we saw some examples where the abstraction level was too high. So we said, okay, no, this is not a good, this is a badly written functional requirement. So we put more detail into it, and we saw that example. Similarly, we looked at the examples where, you know, multiple requirements were jumbled up in one statement. So we said, okay, no, we need to split them and write each requirement separately. So, and finally, we concluded our discussion on specifying functional requirement with some guidelines. We said that we should be careful what sort of language should be used. We should be consistent with the terminology that is used. We should use short sentences, and we have been discussing these things. So it is very important, as I said when we were finishing this particular topic as well on specifying functional requirements, that as an analyst, you should look at who are the users of this particular document, and keeping their backgrounds and their capacities, we should prepare this particular document. And then we started looking at non-functional requirements, and this is a very interesting topic to me, this non-functional requirement, because if we truly understand that what is meant by non-functional requirements, then expressing them is actually not that difficult, and it really actually helps you in producing a better system. Because so sort of we tried to define what are non-functional requirements, and we said that these are actually constraints on the system. And then we said, okay, these are constraints on the system, but what is the difference between the functional and non-functional requirements? So we looked at a very interesting example where we said that, you know, one requirement which said that, you know, only the authorized users should have access to the data. Okay, now that seemed like a safety constraint that I'm putting on my system. And we said that, you know, at times, you know, the way in which, or the detail that you put in a requirement document, it actually, it can change a functional, it can be the difference between, you know, what may seem like a non-functional, we can change it to a functional requirement. For example, you know, we changed this requirement and we wrote it in this fashion, that the system should have an authentication procedure where each user should enter his login and password to enter the or to access the data. So we changed that particular non-functional requirement to a functional requirement. But importantly, we said that, you know, these non-functional requirements, they are constraints on the behavior of the system. So they are related to the functionality that the system should have, but there are some constraints on that functionality. Okay. And then we sort of tried to classify. First we looked at different types of non-functional requirement. We said there are lots of types of non-functional requirement. We have performance, reliability, maintainability, and portability, interface, usability. We have all these sort of different categories or different types of non-functional requirements. But it is important to classify them. Okay. And we looked at a particular classification scheme, which is kind of a very general classification. We said there are 3 classes of non-functional requirements. So I think this is really important that we look back at it. So we said there are 3 classes of non-functional requirements. So we have process requirements, and then we have some product requirements, and then finally we have some external requirements. So and we talked about them, that what is, we try to define them, that what is a process requirement, what is a product requirement, and what are external requirements. So we said that the process requirements, they are constraints on the process of, you know, doing everything to make that particular system. So for example, we said that there are any standards. If we have any standard requirements, then they would go into the process requirement. Similarly, if there are any documentation requirements, if there are any requirements related to how or what kind of tools to be used to develop this particular product, so all these would go or would be classified as process non-functional requirements. Then we talked about what are the product requirements. So we said any kind of usability, performance, reliability, or capacity, size constraints, they would be classified as the product non-functional requirement. Then we finally talked about the external non-functional requirements. So something very interesting that we discussed towards the end of today's lecture is that what are external requirements. So we said that they are constraints on the system, and the external requirement, they are never expressed in the form of shall or shall not have. So a system should always possess these particular requirements. And we looked at examples of deceleration of the train, which was related to application domain, and it also sort of expressed some, you know, laws of physics as well. And similarly, we looked at another example of which was related to the particular application domain. For example, the e-health, that, you know, all the medical records, they need to be secured properly before they are before the system is put into operation. So So this is it from today's lecture, and we have started our discussion on non-functional requirements. We have classified today non-functional requirements. In our next lecture, we are going to continue our discussion on specifying these non-functional requirements. So take care, and Allah Hafiz. Assalamu alaikum.